Okay, this is about solving unusual quadratics. So I'm going to do an example here before we lead into the problem from your book. Hopefully you're already familiar with the quadratic formula. If not, you need to pause this video and go YouTube some other video on the quadratic formula and make sure you feel comfortable with that idea. And then come back and watch this. Okay, so in the example here, we have an x squared term, we have an x term, and then we have this last term r, which we call a constant. What I want you to notice is this multiplier that's multiplying times the x squared, we call that our a. This multiplier that's multiplying times the x, we call that our b. And this constant, the number at the end, we call c. So from here, we already have our variables. We already have our letters named for this problem. A is that value p. B is that value q. And c is that value r. Now, we're usually familiar with these things being numbers, but of course they don't have to be numbers. They could be letters that are standing for some unknown number, like we see in this case. So our quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to go and I'm going to fill in those values. Wherever I see a B, I'm going to put a Q. Wherever I see an A, I'm going to put a P, etc. Here's what I get. Negative Q plus or minus the square root of Q squared minus 4, oh sorry, my pen's not working that well, 4 times P times R all over 2 times P. Now this is a big mess and there's very little I can do with it to clean it up and make it nicer. But it is my answer using the quadratic formula. Okay, so now let's look at your problem. This is number 49 from the book. It says p squared q squared minus p plus 2 equals 0. Part A tells us to solve this for the variable p. So what I notice is I have a p squared, I have a p, and then I have that constant term. So for part A, I can go ahead and name my letters. A is whatever's multiplying times that p squared. B is whatever's multiplying times that p. In this case, it's a negative 1. And c is whatever that constant is on the end. At this case, it's a 2. So my quadratic formula says x equals, but in this case it's not an x, it's a p we're dealing with. So instead of x equals, I'm writing p equals. P equals negative b, which in this case is negative 1, plus or minus the square root of negative 1 squared minus 4 times q squared times 2. I'm sorry, I'm running out of room there. All over 2 times a, which is again q squared. I'm going to clean this up a little on the next line. The negative 1 becomes a positive 1. Inside the square root, negative 1 squared becomes a 1. The 4 times the 2 gives me a negative 8q squared, all over that value 2q squared. Now, this isn't a pretty answer by any stretch of the imagination, but it is the correct answer. P equals this stuff, and we've cleaned it up as much as we're able to. Okay, so now I want to look at that problem from part B, the Q point of view. So now we're being asked to solve for Q. So I want to look, we have a Q squared. We don't happen to have any Q term, and everything that's left over becomes our constant. So when we're naming our A, B, and C here, it's a little tricky. A is whatever is multiplying times the Q squared, which in this case is a P squared. B, sorry, I'm going to rewrite that. P squared. B is whatever is multiplying times that regular Q term, and we don't have any regular Q term. So B in this case is a 0. C is whatever's left at the end, that constant, and in this case we have two pieces to that constant, everything that's not a Q. Because this problem says we're solving for Q, everything that's not a Q is just a number. So now I can use my quadratic formula. Instead of, it usually says x equals, but in this case we're solving for Q, so we're going to say Q equals negative b, which in this case is a 0, plus or minus the square root of b squared minus 4 times a times c. Now c is two terms, so I have to write in both that negative p plus 2. I'm going to try to write that a little neater in here. I have my b squared minus 4 times a times c, all over 2 times a. Okay, so I'm going to clean that up a little. First, negative 0 is just 0. I don't have to write a 0. So I'm going to start with the plus or minus piece. Inside there I have a 0 squared, and that's just 0. So now we're just looking at this piece. The 4 times the p squared times the negative p plus 2. I'm going to clean that up a little in just a minute. So in my final line, I have plus or minus, and I'm going to distribute that negative 4p into those parentheses. What I get is a 4p to the third and a negative 8p squared all over 2p squared. Now, those are both pretty confusing, but remember, it's just about looking at what they're asking us to solve for, identifying those terms, and identifying our A, B, and C, and plugging them into the formula. Hope this helps.